First of all, thank you very much for the invitation. Thank you, David. Thank you, Louisa. Thank you, John, and everybody else. Thank you for attending. Now, I'm being recorded, so I have to look very much after what I say. And also, for the cameras, I tend to move a lot. So even because if I stand here, you don't see me. So probably better sort of stay a bit closer to the center of the screen. What I'm going to present today is essentially a journey that started about 10 years ago when I was assistant professor in Australia, and I started being interested in daylighting. I was part of a mobile laboratory, which was one of the first few people that, like Ghostbusters, started to look inside buildings and try to see how people effectively felt inside building, other than just relying on simulation and design plans and so forth. After that, I moved to Nottingham, and I had the greatest chance of my life of meeting Michael Kent, who is now sitting over there, who about 4 years ago had the crazy idea, after having been one of my students in one of my undergraduate courses. About 4 years ago, he had the crazy idea of asking me to become his supervisor for his PhD. So from there, we started a relationship which actually has gone much more than just sort of supervisor and PhD student, because we were actually writing each other at 3 o'clock in the morning saying, we should do that in that experiment, we should do that, and so forth. So certainly his enthusiasm and hard work is one of the most important elements that's actually brought us here today to present this work. I want to start also with some acknowledgements. Although I'm sharing this presentation with Michael, the work would have not been possible without the wise supervision and advice of Professor Peter Tregenza, who has actually followed myself and then Michael for a number of years. Then Jan Fienold from EPFL in Lausanne, particularly in the test room studies that Michael will present in the second part of the afternoon. Steve Photios from Sheffield, who was actually a very challenging examiner for Michael. And then Robin Wilson and Peter Rutherford from the University of Nottingham, who were also part of the supervisory and examination team. What I'm going to do today is essentially present the overarching aim of the research, which is the investigation of temporal effects on glare response in the presence of daylighting. This overarching aim has been articulated in three sub-aims, in 3 parts, 3 studies. So the first objective is to examine the effect of time of the day under controlled artificial lighting conditions on glare response given by test subjects. So the first is really laboratory condition, is what we call the effect detection stage in terms of the analysis of the effect of time of the day on glare response. The second part is exploring the influence of temporal and personal variables on glare response. So try to understand if there are some of the factors which have not been accounted for in glare formula that could actually be, in one way or the other, responsible for some variation in terms of glare response along the day. And then the third part is to analyze the influences which have been detected in the laboratory conditions under a semi-controlled daily office test room study. I'm going to present the overarching structure of the work. I'm going to present the first of these objectives, start on the second, and then Michael in the second part of the afternoon will talk us about, will actually explain the test room studies and the methodology that have been put in place in order to reach the conclusions of the work. So obviously in here we're talking about discomfort glare that Peter Boyce defined as an annoyance or distraction caused by sources or non-uniform or high luminance in the field of view, obviously, as you all know. And also discomfort glare is something that a lot of literature says that has not yet been fully characterized. Responses to discomfort glare can obviously span from mild irritation to extreme distress, although discomfort glare does not necessarily impair task performance or visibility. That obviously is disability glare, which is much better characterized within the literature. One thing, I've left the PDF of this presentation to David, and I'll be more than happy to give you all of the slides. And all of the work that we present today has been published in 2 papers in lighting research and technologies and 2 papers in building and environment. So all of the information is effectively available, but I'm more than happy to give you the PDF. One of the things that is important in terms of discomfort glare that Peter Tregenza defined as sitting on a 3-legged chair. So essentially something like you can still live with it, but after a while you obviously start to feel that something is wrong in your setting, is that when discomfort glare is present, an observer would likely react, for example, drawing on the blinds and reducing the amount of daylighting, very likely, as we know, due to human inertia for the rest of the day, if not the rest of the winter season or whatever, if not forever in a building. Does this one works also with a pointer? Is this? Yes. These were images that I took about 10 years ago while I was doing a post-occupant evaluation analysis of daylighting in a building in Melbourne. This is winter and this is summer. One of the things that actually got me to understand and study discomfort glare is that in winter there were much higher chances for the occupant to be disturbed by glare due to the ratio of luminance on his field of view. In summer, at the same time, 9 o'clock in the morning, the sun was much higher, there was much lower contrast ratio in his field of view, but he had his blind down. And obviously I interviewed then the occupant and said, okay, so you have a contrast ratio which is actually higher than 1 to 20, and DGI, I can't remember what it was, so I'm gonna specify here the use of blinds in the winter season. And he goes, no, please don't do it, because in winter, when the sun is out, that's the only way for me to wake up. So I know that the sun is there, I just try to do something else, but without it, I wouldn't actually feel awake for the rest of the day. Then I asked him whether he was working or driving at work, and he said that he was driving. So essentially what I thought is that this person in winter had not had sufficient daylight illumination in the morning in order to entrain his metabolic cycle, while probably in summer he would have been out in the morning, or maybe in summer he would have walked to work, hence he didn't need the presence of a high level of luminance in order to entrain his cycle. So obviously I thought there must be something else that in a way or the other affects our reaction to discomfort glare. Obviously we know that there are a number of formulas and indexes that have been produced in order to predict the occurrence and magnitude of discomfort glare, and most of them actually look something like this. So consider luminance of the source, luminance of the background, solid angle of the source, and then the position index. Of course, we know that daylight glare probability has brought to the fore the presence of vertical illuminance that we also know being a proxy for metabolic stimulation. But one of the problems with these indexes is that when we then regress the results of the glare indexes against the glare response given by subjects, very often we have a very large scatter. So very often the level of predictability that these indexes is actually quite low. So there must be, or there could be, some of the factors which are not considered within the photometric and physical conditions that enter within the formula that can influence glare. As we said before, non-visual stimulation is actually linked, obviously, to the, has been linked to the time of the day and the duration and intensity of daylighting that enters at the retina. So in a sense, the kind of research question that together with Zetagenza and with Michael we started to work upon was, is there an effect of time of the day on the glare response which is given by subjects, particularly in the presence of daylighting from windows? The reason why we say particularly in the presence of daylighting from windows is that, of course, we know that the way in which glare indexes work is somehow impaired when we have a large source of luminance and when we have a number of other conditions, like, for example, daylighting. So we started on with a research that essentially was systematically trying to resolve the two main sources of variability that we can find in terms of looking for the response of a test subject from a physical stimulus. So on the one hand, we have the what, so the time of the day, and on the other then we have the why, all of the variables that we have to consider in order to try to resolve and try to justify those two main reasons of variability, so the within subject variance and the between subject variance. In order to do that, we had a systematic way of arranging our research where, first of all, of course, we have to generate an hypothesis. So glare sensation is associated with temporal variability. Then we have to identify the variables that we need to test and try to control or mask from the experiment a lot of other variables that we know could more or less have a measurable outcome. Then obviously we have to design experiments in order to measure those variables, and the experiments can actually be controlled or semi-controlled, Obviously, the following stage will be the uncontrolled experiment, which is obviously the field, and then analyze data in order to quantify variables and draw provisional conclusions upon which we can then move to the following stage. So the research was essentially based upon the hypothesis, is there an effect? An identification stage where we could actually look at both the intra-individual differences and the inter-individual differences. So the difference between one subject and the other, but also the difference within the subject, so different responses at different times of the day. And that has been the main challenge for the design of experiments, because we had to do experiments that, in the way in which they were arranged, they allowed both a repeated measure design and a between study design. Hence the reason why we then move on to the methodology of the work. Doing this and having different experimental design methodology also allowed us to analyze statistically the data in different ways in order to explain the within subject variance and the between subject variance. This all culminates to then the work that Michael is going to present in the second part of today's presentation on the fitting of a multi-level model, where we have considered both a fixed variability that can explain the within subject variance and a random variability that can explain the between subject variance. If I'm going too fast, if I'm boring you, if you don't follow me, I know. I mean, I was also saying to Luisa before, I deal every single week with 200 teenagers. So getting them away from Facebook or from posting weird pictures of me on YouTube is actually something that I deal with on a weekly basis. Not that I'm successful at that, but anyway. So we started off from a laboratory study. The research question is there an effect of time on day on glare sensation? The hypothesis is that we assume that this effect is general. So if the effect is general, it can be detected by means different from daylight from windows. We do that because obviously within a control experiment, we can obviously control most of the variables that we know affect glare, but also try to mask statistically a number of other variables. So in this case, within this experiment, we also considered a homogeneous group of observers in order, for example, to avoid having to consider variability due to age or schedules or different times, for example, of lunch and dinner and so forth. And also we tried as much as possible to have a systematic analysis of all the temporal and personal factors that were alleged from the literature to be somehow varying with the variation in glare sensation. This is the test chamber that Michael built, where we have an overhead background lighting, a glare source of reference, and then a diffusive screen that provided the glare source. Actually, probably it's better to present it in plan. So essentially, this was a semi-hexagonal arrangement where the head of the subject would actually be in the middle. Then we had a projector which was connected to a computer, and by connecting the computer, by using on a computer an image editing software, we could change the relative brightness that was produced by the projector and then projected onto a diffusive screen. The projector had, then we measured obviously the mean average luminance that was produced by the diffusive screen, and we could actually link to a polynomial fit from the calibration of the projector on itself. The background luminance was kept at a constant 65 candela per square meters, and then obviously all of the potential covariates and extraneous variables that could be considered within the experiments were either measured or isolated. All of the background luminance was checked with spot point measurements, 17 of those, in order to make sure that we could actually maintain those conditions exactly identical for all of the test subjects. Within these experiments, we had a number of different elements that we had to consider. First of all, one of the big challenges was to try to understand what is the temporal distance between sessions that could allow to detect the effect that we were looking for. For this, we did a number of initial pilot studies, and from the pilot studies, we could actually see that the differences between sessions that were spaced at less than 1.5 hours actually did not return any statistical significance. So at the end, we decided to have 4 different sessions throughout the day at which participants would give their vote of glare sensation. This was scheduled at 9, 12, 3, and 6 p.m. So we had a morning, midday, afternoon, and evening session. We organized the study so that we could actually measure 2 people per day. This was done between the month of January and March. The reason why we wanted to measure 2 people per day was to minimize as much as possible the impact of seasonal variability on glare response. So try to reduce as much as possible the time in which the experiment would have been run. In order for people to give their vote of glare sensation, we used the adaptation of the glare sensation votes, which are described in the work of Vels in a thesis of 2002, where each vote of glare sensation from GSV of 0 to GSV of 3 are referred to a time span descriptor. So, for example, the just perceptible that refers to a glare sensation vote of 0 is referred to the borderline between imperceptible and perceptible glare, where glare, as represented by the point, where glare is first perceived by the subject. And so forth, we had the time span descriptor. For example, just noticeable is the glare the subject could tolerate for approximately 1 day. Just uncomfortable is a glare that could be tolerated for approximately 15 to 30 minutes if the task took this amount of time to complete. And just intolerable is a level of glare sensation at which people would immediately react and change their conditions. Obviously, this was in order to make sure that even people that were naive with the concept of glare could immediately recognize the meaning of those glare sensation votes. 30 subjects volunteer to the study. Is obviously very useful when you're teaching a daylight in class and you say, okay, there is this beautiful experiment and please you all volunteer to the study. And normally students are actually very keen on to demonstrate their willingness to participate, which was actually an advantage because, as I said, since we had a very fixed schedule, 9, 12, 3, and 6, we could organize that in days where we knew the students did not have lectures, so in order not to disrupt their normal routine. And also it was a relatively homogeneous group of subjects. The test started by asking subjects to first look at the reference glare source and to adjust its brightness up until the brightness of that source was considered by them to have reached each of every GSV. So essentially, a subject would sit there, start playing with the dimmer, and then increase the brightness of the reference source up until it said, yeah, more or less now is 0, 1, 2, and 3. So that obviously allowed the people to familiarize themselves with the experimental setting and also give them a clear understanding of the range of luminance that they would have been subject to. The range of luminance was in the previous slide was between 400 and 20,000 candela per square meter. Then the real experiment began, so the reference source was switched off, and then the projector was switched on, which produced the luminance on this diffusive screen here. So the luminance was gradually increased at a constant pace, and then the subject would actually essentially say, now GSV 0, 1, 2, and 3. And we would record the brightness of the screen that corresponds to that vote, and then from that, from the luminance measurements that were previously taken, ESGI, so the Illuminating Engineering Society glare index, was calculated. We also calculated the UGR index, but then the results were found out to be exactly the same, because the only difference really is with one of the main differences actually in the exponential value that is put onto the luminance. But obviously in this case, only the luminance of the source is changing, because all of the other parameters, the background luminance, the position index, and the solid angle is the same. One of the tests that we did is to use the log luminance as an estimation parameter. So essentially we calculated these IES-GI corresponding at each level of glare sensation. Obviously, if people at different time of the day give the same vote of glare sensation for photometric conditions which are different from the point of view of IES-GI, then we can say that there is an effect. there is an effect that in one way or the other has caused people to give the same vote of glare sensation for a different luminance or for a different condition in terms of the photometric parameters. We did a first analysis of the data, obviously, in order to understand what sort of tasks we could do. So we did a graphical and statistical analysis of the data, which revealed non-normal sampling distribution. In this case, you have the QQ plots, where you have the null hypothesis. So in this case, the normal distribution, which is plotted as a diagonal line. We can see that data deviate from this diagonal line, hence we can actually infer that data were not normally distributed. And also we checked for the Levine's test of homogeneity of variance. Due to this test, we then adopted non-parametric inferential analysis to the data, and in particular, we adopted at the first stage a Friedman's analysis of variance in order to compare the IESGI, so the glare indexes, for different test sessions against each other. Obviously, as I said, variations in IESGI for the same glare sensation vote will indicate that the effect of the factors unaccounted in the formula are influencing the glare response, in which case, obviously, the factor unaccounted in the formula would be the time of the day. Inferential tests were obviously based on the null and alternative hypothesis that the cumulative scores of the ranks associated with the independent variable were not equal between morning, midday, afternoon, and evening sessions. If the Friedman's ANOVA reveal statistical significance of those differences, and therefore a rejection of the null hypothesis, then to isolate the main effects, we did pairwise comparison by the Wilcoxon match pairs or sign rank test. Within the pairwise comparison, we gave a particular emphasis not only on the statistical significance of the results, but particularly on the effect size, which is something that I think is now becoming something very important within scientific research. It was the last issue of Lighting Research and Technology where Peter Boyce started with an editorial which was called The Size Does Matter or something like that, where essentially says that obviously the detection of statistical significance is only one of the first steps that you should have when you have a test done with human subjects. What really matters is the size of the effect that you have detected and whether that size is or is not practically relevant. Especially if you deal with large samples, which is actually very common if you have a repeated measure design, like in our design study, is actually very common to find statistical significance of results, because there is a difference. There is a difference between people. We know that people actually are different from each other. But then what is important is try to give an estimation of what is the size of that difference and whether that size is of a magnitude who is practically relevant in terms of the effect that you're trying to detect. For the effect size, we use some very conservative benchmarks, which are benchmarks which were published by Ferguson in 2009, which are much more conservative of the traditional benchmark that Cohen published about 20-25 years ago. This is the first plot that came out of our first analysis. Essentially, what we have in here is the different votes of glare sensation, just perceptible, noticeable, uncomfortable, and intolerable. We have the IESGI on the y-axis, and then we have the box plot of statistical values. So essentially, we have minimum, 25th median, to a 75th percentile, and then maximum. For each vote of glare sensation, we can immediately see that as we go along from morning to midday to afternoon and evening, for each of these votes of glare sensation, there is a tendency, a trend, for statistical values to correspond to higher level of IESGI as the day progresses. So for each of those 4 glare sensation votes, a tendency is apparent from graphical analysis of the display that seems to tell us that the IESGI increases as the day progresses. An IESGI that increases means essentially that people were given the same glare sensation, just perceptible, for photometric condition that corresponded to a higher glare index. Therefore, we could actually infer from this graphical display that people would tolerate a much higher source luminance as the day progresses. Obviously, this is just an initial inferential analysis from the graphical inspection, but even when we plotted the same data against the log luminance, which is probably something which is easier to understand and easier to communicate, we could actually see exactly the same trend. So in this case, we have the 4 test sessions, morning, midday, afternoon, and evening, and we have the 4 glare sensation votes. In this case, we see even more clearly that under each session and under each glare sensation vote, as the day progresses, people seem to tolerate a much higher log luminance for the same level of glare sensation vote. Another thing that we can actually start to see from this graphical display is that the effect of time of the day is not uniform across GSV, so we don't have a constant, let's say, variation of the glare index as we go from, say, just perceptible to just noticeable and so forth. And also that differences seems to be more substantive with a larger time gap between the session. So essentially comparing morning to midday, or probably the following one will give us a better visualization. Comparing morning to midday or comparing morning to afternoon will give us a larger variation of this glare sensation vote. Obviously, these are all conditions that we see from the graphical displays, but we had to do some statistical analysis in order to see whether these inferences were substantiated or challenged. The Friedman's ANOVA detected highly significant differences for each of the 4 glare sensation votes. So we can say that there is statistical significance which comes out of the analysis of variance. So in order to see where those differences were, we did the Wilcoxon sign rank test with the testable hypothesis that subjects became more tolerant to glare at later sessions. So it was a one-way analysis. What resulted from this is big tables, such as this, where essentially we have a pairwise comparison between test sessions for each glare sensation vote. So for example in here, for the glare sensation vote of just noticeable, we see a pairwise comparison between the midday versus the morning session. We have the median and the interquartile ranges of the ISGI at each of these sessions, and then the difference between the medians. If those differences are positive, it means that you would have a higher median in the midday with respect to the morning. Therefore, the ISGI would tend to increase throughout the day. One of the first results that we see is that all of those differences in median are positive, and so are the effect sizes. Therefore, we can infer from this that the value of the median at a later test session is always higher than the previous one. So in this case, for example, the ISGI that is measured, the median of the ISGI measured at the midday is higher than the ISGI measured at the morning. The ISGI measured in the afternoon is higher than the morning, and the one in the evening is higher than in the morning. If we then look at the way in which those differences in medians change and the effect size change, we can see that there is a clear indication that the difference in median and the effect sizes tend to increase as we go along the day. Therefore, for each comparison, the inferential test confirms an increase in glare tolerance along the day. Obviously, this is just noticeable that I've put it here as an example. I'm not going to go through all of the single data. However, I've put them in the presentation because if somebody wants the PDF, I think it's fair enough to have all of the data that are part of this work. However, the same conditions are actually found for each of the 4 glare sensations that we use for our analysis. Another thing that we did, we plotted the log luminance, so the candela per square meters at which people reported different glare sensation in the morning, and then we plotted the midday in one case, in the evening in the other case, log luminance at which people gave every single glare sensation vote. Obviously, if the glare sensation is only dependent on the luminance of the source, luminance of the background, and position index and solid angle, we would expect this to be exactly the same. So we would expect all of the votes to be on the null hypothesis, which is the diagonal line. We see, however, that there is a large scatter, and we also see that the regression line, we also see that the regression line are always higher than the null hypothesis line. In this case, if they're higher than the null hypothesis line, it means that the ISGI at the latest test session, so midday with respect to the morning and evening with respect to the morning, will be higher. So people could tolerate a higher level of glare sensation, of luminance at later parts of the day. One of the things that we see in here, however, is that data are very much scattered. And actually, we could see that there is both a between subject variance and then a within subject variance. So although we can say that there is an effect of time of the day, or at least the data seem to indicate the presence of an effect of time of the day, still there is a lot of scattering in the data, so there is a lot of unexplained variance in the model. So we cannot stop here. And I will not stop here, although I'll maybe pause in order to make sure that if there are questions, I don't want to go along and then sort of leave doubts behind, and also I'm going to go and get a glass of water. Is it okay? Yes?
Just a quick question. What was the explanation why people tolerate greater luminance in the afternoon than the morning?
Well, we don't know. At the moment, this is what we call the effect detection stage. At the moment, we're looking to see whether in a controlled laboratory experiment, we could detect an effect of time of the day. Obviously, like most of our analysis, we don't necessarily have a causality. So we don't know whether time of the day causes a difference in terms of the luminance which is associated with the same glare sensation values, or whether there are other variables. Hence the reason why this is just the first of 4 different experiments that we did. I hope that by the end of the afternoon, some of those questions may be answered. Yeah, John?
Was there a seasonal signal, or am I preempting something?
No, well, that's why we did 2 test subjects per day. We tried to pack the 30 subjects within 2 weeks. So we tried as much as possible to minimize the effect of changing conditions or changing season.
But you got data from different...
We got data from different people and...
different seasons as well, did you?
No. It's all of this was within 2 weeks. The experiment ran from the end of January to the beginning of March, and we started with a pilot study of 10 people, probably the first week. Then all of the data collection was within 2 weeks, and then all of the analysis. So we tried as much as possible. That was one of the reasons why we started with a laboratory setting, and one of the reasons why we tried as much as possible to minimize all of the other potential conditions that could have affected the glare response. Yes?
Would it be appropriate to infer from what you've shown so far that the greatest change was in between morning and mid-morning, and the latter stages had rather less change?
We could be doing that. Actually, we could do that by just looking at the difference in effect size. Actually, the largest difference is, in here we are comparing midday versus morning. We should really be looking not at the difference in median, but at the effect size, or the magnitude of the effect. And we have 0.48. So an effect which is at the borderline of moderate. We use the benchmarks by Ferguson, where 0.20 to 0.50 is small. Although it's small, actually, it is called small, but it's still a relevant effect. So the largest effect, I think, in this case, if we look at it's between the morning and the evening. Essentially, as you increase the time span between sessions, you have a more practically relevant changes in magnitude of the effect.
What I was perceiving was the difference between each session.
Yeah.
Got more slight.
Yeah, probably the largest is between the morning and the midday, which led us to one big question mark, whether there was any effect of learning in the test. So after we did this, we started to say, okay, but hold on a second, yes?
Could you consider using an earlier test time as well?
We did, and this is probably something which we didn't actually do within the tests because we didn't want to disrupt the schedule of people. So we wanted to test them within a normal day. At the very end of today's presentation, Michael will present what is now his postdoctoral research, which will probably get us a few headaches in terms of headache clearance, because we want to test people in the middle of the night, I suppose, and also at the very early stages of the day. But the question that you ask is actually very pertinent, because obviously we have a very marked changes in terms of luminance between the first and the second session.
But
So
if you plot the day's luminance just under a sky condition,
Yeah.
on a logarithmic scale, there's a sort of big heap, and it
Yep.
goes to almost a plateau, flat plateau, then down again. So
Yep.
the biggest change that we experience on an animal level is
It's
in a relatively short
period of
beginning
time.
and end of the day.
So this is, well, of course, something that is actually also very important, because we were discussing earlier in terms of the way in which you design buildings. And obviously an east-facing window and a south-facing window will actually have direct sunshine at different times of the day, where your body could actually tolerate more or less of that luminance. So obviously this is something that clearly needs to be taken into account.
So just a quick question, did you change the order of the sequence in which?
Where that's exactly what we're saying now. So the very first experiment, actually, we did not change the order, the sequence of subjects. So essentially, subjects started from morning and then came midday, afternoon, and then evening. So one of the questions obviously was whether there was any learning or experience effect. For example, Hopkinson said that initial session could actually be biased by inexperience or anxiety about the test, or also the fact that people did not know up until when the glare source would have been sort of increased. So in a sense, they probably did not feel so comfortable as in following sessions. So we did another quick study, a follow-up study with 8 subjects. And the research question of this was, can difference in glare sensation vote be detected over 2 consecutive days using the same subject? So essentially, a subject would come in on day 1 and have the session morning, midday, afternoon, evening, and then we would record obviously the glare sensation votes and their difference, the eventual difference in glare indexes or log luminance at which those votes were given. And the following day, it would repeat exactly the same session. If the tendency is the same, then we can exclude safely any effect of learning or experience from their response. Again, we had the PGR students in this postgraduate research students in this study, and also we recorded some confounding variables, so fatigue, sleepiness, food, caffeine, and so forth. This was because from analysis of the qualitative comments that subjects had added to the questionnaire, most of them, for some reason, said that they were much more fatigued on the second day. So we thought that it would have been important to control and to mask the effect of fatigue from the data. Again, we did the first analysis of QQ plot and analysis of normality and Levin's test of homogeneity of variance. In this case, those assumptions were not violated. We had actually a much lower number of subjects, so we used parametric tests for this analysis. And we use analysis of covariance, so as ANCOVA, utilizing fatigue, as I said before, as a covariate. So essentially, in this case, we try to explain the variance in the model by using an analysis of covariate that essentially masks from the effect of fatigue. So we can eliminate the variance which is associated with the fatigue from the data in order to make sure that we can actually explain the variance which is existent in the model. The results actually provided, probably I better just sort of put it up. I know it's a number of data, but I just want to emphasize, that all of the differences that we detected between the first and the second day were non-significant. So essentially, we couldn't actually have a solid basis on which to infer that the variation of glare response from the first to the second day would have needed to be considered in the results. And if we look at the effect sizes, obviously the effect size is very small. In this case, we use the partial eta square as an estimator of the magnitude of the effect. They were either negligible or very small. Hence, from this second experiment, we could confidently exclude that there was any effect of learning or experience from the results that we had before. However, still, the large scatter that we had detected remains something that needed to be explained. There was still a lot of variance between subject and within subject variance that could not be explained within this model. So essentially, from this first experiment, the sort of outcomes were that there is a substantive, we use this term, which is very much within the psychological sciences. It's not substantial, but substantive, meaning that it's practically relevant. There is an effect size which is beyond the benchmark of practical relevance of magnitude. There is a substantive influence of time of the day on glare sensation. We don't know whether this influence is a causation influence or any other sort of association with the outcome variable. In fact, the glare sensation votes were reported higher levels of glare index as the day progresses. There were differences in tolerance which were more evident with a larger time gap between sessions. So the difference in tolerance between morning and midday was, the difference in tolerance between morning and evening was larger than between morning and afternoon and larger than between morning and midday, although we could not recognize a constant gradient in that variation. And we could actually safely exclude an effect of learning from the data. Still, a large scatter was detected, so we could actually infer that further factor could cause individual variation in tolerance to luminance increases. Despite evidence of fatigue, the effect of confounding variables was not consistent. Also, there was one other aspect which sounded somehow out of place in this analysis. Due to the source luminance that we were using, the glare indices were lower than expected. So subjects may have had some difficulty in assessing glare sensation, maybe due to the abstraction caused by the artificial setting, or maybe due to the fact that there was no visual task stimulus which was associated with their rating of glare. So from this, we designed two further experiments. Two further analyses. One analysis was a further analysis on the data that we just presented, and the other one was a brand new experiment. When we did, yes?
I'm sorry to interrupt.
Absolutely, I mean, I think that's...
What you just said was pertinent to what I was thinking, is that in terms of the interpretation of glare by the subjects, if there's variation in that would cause scatter in the results. So
yes.
Whilst you considering that in terms of the of the investigation in setup, that actually the people's interpretation of what you've said to them, allowing them to make the assessment, may be part of that.
Absolutely. I think this was one of the most substantial point of debate between Michael and his PhD examiner, which was Steve Photios, because obviously Steve, he wrote recently last year on Lighting Research and Technology about the potential bias in measuring or assessing glare, particularly in that borderline between comfortable and discomfortable. The first experiment we used just perceptible, and we use a GSV of 0. So what Steve was saying is, obviously, I mean, it doesn't matter because we really use a time span descriptor, so people could relate to that. But a 0 is associated with a just perceptible vote, which means that there is the perception of glare. So essentially, there is no null hypothesis, there is no presence of glare. Hence the reason why in following experiments we use just imperceptible, and also we varied the scale for the glare assessments in order to make sure that we could actually use different forms of people giving us the feedback. In this case, we use a 4-point ordinal scale. In the following experiment that I'm presenting, we use a visual analog scale, which is probably could be more understandable by people in terms of putting a line on a 10 centimeters long visual analog scale. So we tried as well to consider differences that could have occurred in the way in which people would interpret the vote of glare sensation that they had to give. I know. Well, this is when Steve actually examined Michael. I remember I told him, okay, I've booked the room for 2 hours. And he said, Sergio, I have 18 pages of comments, so book the room for the day. It was 4 hours and a half long PhD viva. So
one of the things which I think is interesting about glare, but it's so difficult, is that, and if I can just speak from personal experience, is that if you're in a very bright interior, you can have glare.
Yep.
And it's actually negative to the, we consider glare from a light source because that's the way we've described glare, starting with the electric light industry. The trouble for us in the daylight world, where we start with very large sources, is that actually it doesn't really fit the same set of rules. And I've just from personal experience of working in the display and museum field, is if you, for instance, you paint all the walls white, you have something relatively dark on the wall to regard, to look at, you're getting glare from the majority of the volume, not from the minority.
Which is the big challenge when you do semi-controlled or uncontrolled studies. So when you actually move to the field, because the number of variables that you have to consider is obviously much higher if you can actually sort of control all of them. In this case, obviously, we tried as much as possible to minimize the occurrence of any other potential factor that could influence the effect that we were trying to detect. And one of the things that obviously we had to consider is the difference between, obviously, as I was saying before, the within subject variance and the between subject variance. So on the one hand, we consider the difference that the assessment that one person gives on different occasions, so on a repeated measure design. So the assessment which is given at the morning, at the midday, afternoon, and so forth. But then we have the between subject variance, so the difference between me and another person under the same condition at the same time, giving obviously a different assessment of glare sensation. So those two components of variance had to be included within the model. In order to do that, we tried to look at whether there were other factors varying with time of the day that could be associated with a change in the glare sensation vote, which is given by the subject. So from the previous test, when subjects actually enter the test room, we asked them a number of things. I had to fill in a very short questionnaire asking them obviously demographic information, age, gender, ethnicity, self-evaluation of personal factors, so their self-assessed photosensitivity and their self-assessed chronotype. Chronotype is essentially an intrinsic factor which essentially could be associated at the time of the day where certain metabolic functions are activated, or could more easily be seen as the difference between morning people or night people. However, in order to do that, in order to get that assessment from people, rather than asking, are you a morning person or are you an evening person, we use the Munich chronotype questionnaire that gives a number of different questions in order to define then the chronotype of people. And then we ask people to self-report temporal variables, so their perceived fatigue, the caffeine in food ingestion prior to the test, the prevailing sky conditions they had been exposed to before the session, and then whether they had been exposed to artificial or natural light before the tests. These are part of the questionnaires that we used. So obviously this was part of the demographic. Then the photosensitivity questionnaire, which is something like, do you use window blinds, do you often wear sunglasses and so forth, which obviously is relevant if you are, like I am, from South Italy. If you are from Nottingham, you say, sunglasses, what are they for? Anyway, obviously you have to consider those different things. Then subjective fatigue scale, we used the Samparelli 7-point scale. We had the Munich chronotype questionnaire, the Karolinska sleepiness scale, and then obviously the temporal variables in terms of ascertaining whether people had had any caffeine and so forth. This was self-assessed. So again, there's a limitation in here because you're asking people to self-assess how much caffeine, whether they've had caffeine. We're not asking how much caffeine. So obviously, if we really wanted to control this parameter, we would need to have a control group where, for example, we did not have any caffeine ingestion, and an experimental group where we give either caffeine pills or so forth, if we wanted to really do this in a more systematic way. Again, we use the same data, so 30 subjects, and we reduced the variables in either dichotomous, so yes or no, caffeine or no caffeine, or in ordinal scale. Particularly fatigue was measured on a 7-point ordinal scale, and chronotype as well was measured on a 7-point ordinal scale. Obviously, for these two different type of variables, we had to use different statistical tests. So we used the Mann-Whitney U for the dichotomous variables, and we used the John Curie Testra, which I'm going to call JT because I really cannot pronounce it, for the ordered variables. Again, we did analysis of distribution of data and the Levine's test for homogeneity of variance, and we actually saw that the data were not normally distributed, so we used non-parametric test. From initial analysis of the data, we found no significant difference based on gender, ethnicity, age, photosensitivity, and food intake, so we excluded that from further analysis. And again, the emphasis of the inferential test was placed on the effect size. These are the results that we had for all the variables. Again, I've put in all of those big tables where you have all of the data. I'm not going to go through that, but I thought that it was useful if you have the PDF to get the full data. This is the way in which we have ordered subjects. So we use the 7-point Samparelli scale that goes from fully alert to very lively up to completely exhausted. What you have in here in the box plots, you have the 4 sessions, so morning, midday, afternoon, and evening. You have the ordered categories of subjects, and then you have as an estimation parameter the log luminance, so the luminance of the source at which people gave the same glare sensation vote. The first graph is referred to the just perceptible, so the GSV equals 0 point on the scale, and this is referred to the just intolerable. In here, we cannot see any prevailing tendency. We cannot see whether people, depending on their level of fatigue, tended to have a more or less higher source lumina associated with the glare sensation vote. So we use a two-way analysis. We found some significance in some of the data, but the significance was actually going in 2 different directions. So for the just perceptible, we found an inverse relationship. So people more fatigued gave the same glare sensation vote for a lower source luminance. And for the just intolerable, the findings reveal a direct relationship. So a direct relationship between an increase in fatigue and increase in source luminance. So essentially from this data, we couldn't actually infer what the influence of fatigue was on a glare sensation. Again, this is in the table, and these are the 2 parameters, that I just discussed about. So in this case, in the afternoon for the just perceptible, we see a negative effect size. So a negative effect size in a JT test is a way for looking at the trend in the data. So the directionality of the relationship between the variables that we are considering, in this case fatigue and the source luminance. On the other hand, the other significant test is for the evening in just intolerable. In this case, is a positive trend. So from this data, we cannot really infer whether fatigue has a direct or inverse relationship with glare sensation. Interestingly, then, we moved on to chronotype. So essentially, whether people self-assess themselves as extremely early or rather extremely late, although both the 0 and 6 were not part of the data that we collected. In this case, from the analysis of the box plot, we can see that there is a direct relationship between chronotype and glare sensation. So for example, if we look at the just intolerable glare sensation vote and the morning session, we see that as people go from type 1, which is extremely early, to type, well, in this case 5, which is moderate late, the same glare sensation is given for a log luminance which is decreasing. So the earlier you are as a person, the more likely you are to tolerate a higher source luminance for the same glare sensation vote. So this is what is a tendency that appears in almost all of the box plot, and that was then substantiated by the inferential analysis. So in the data, we had a consistent negative sign of the test statistic and the effect size, meaning that there is an inverse relationship between variable. So the inverse relationship was significant and with a substantive magnitude of the effect. So earlier chronotypes could tolerate higher source luminance for all level of visual discomfort. Again, we moved quickly to the data. So for example, we looked at just intolerable. In the case of just intolerable, for example, in the morning session, there is a negative effect size, which is significant, which means that in this case, the earlier the people are, the higher the log luminance that they can tolerate for the same glare sensation vote. Obviously, this is based on a Munich chronotype questionnaire. It's not based on any detection of effective biological or metabolic data, like, for example, your melatonin level or cortisol and so forth. So this is the reason why then Michael will actually talk about at the end of the day all the experiments that he's actually planning in terms of the analysis of chronotype. Caffeine ingestion, again, in this case, we had dichotomous variables. So we had no caffeine, which is the white box plot, and the shaded is the group that had actually declared to have ingested caffeine before the test. There is tendency in this case for the people that declare to have ingested caffeine to have the same glare sensation vote for a lower luminance. So essentially, it seems like people that had ingested caffeine had lower tolerance to glare, so they declare the same glare sensation vote for a lower luminance of the glare source. Again, we did analysis on this data. We could found some significance within the data in itself. One thing that we have to remember from the inferential analysis that I can then plot in here is that all of the effect sizes in this case are negative. This is not an indication of an inverse trend. It's one of the characteristics of this test. This test actually detects statistical significance by ranking the data, so it's a non-parametric test. In ranking the data, it takes the lowest sum of ranks as the test statistic. So the effect size, so the z-score and the effect size will always be negative. So the directionality of the hypothesis has to be considered by looking at the difference in the median value of the two groups. And then obviously the effect size will tell us about the practical relevance. I hope I was able to say it in a simple way. Yes?
Probably a big number, but I think from this we can infer that maybe people taking caffeine, they are more likely to have glare at night when driving, to be awake with it.
Well, yes, this is actually one of the conclusions that we had out of the following experiment, because obviously at this point we see some scattered significance and we see some effect sizes that go in different direction. So we designed another experiment in order to look at whether there was any relationship between caffeine and glare. And one of the things that actually came out of the experiment, I'm just telling you right before, is whether caffeine could actually mask fatigue. So essentially, whether there could be a link between fatigue and glare sensation, and whether the more fatigued you feel you are, the more likely you are to have ingested caffeine. So the presence of caffeine in your system maybe does not have an effect on glare, but maybe is masking caffeine. However, very recent research by Burke told us that caffeine has an effect on your metabolic response in terms of your melatonin abatement, up to 40 minutes, I think, for every single 40 minutes delay in your phase response curve for every single espresso cup of caffeine or something like that. Although this was part of a very recent experiment that they did, and obviously all of this data will need to be further analyzed in different conditions. But yes, I think that that's one of the elements that we're trying to sort of look at. Sky condition. In this case, we asked people to rate the sky condition and to distinguish between clear sky and overcast sky. We had actually a bit of a trouble in having this as a dichotomous variable, because we told people that partially cloudy sky should have been included under clear skies. So obviously, I mean, we have to take all of these results with a pinch of salt. As we could see from the box plots, and as we could see also from the inferential analysis, there is no clear directionality of the hypothesis. So again, in some cases we see an inverse relationship, in some cases we see a direct relationship. So the way in which log luminance and glare source are related to glare sensation vote are related to each other. This is again provided in the results because no statistical significant differences across the 6 comparisons were detected. Although we found effects to be practically relevant in some cases, which means that there is some indication that the prevailing sky condition has an influence on your glare response. And one of the interesting things was that all of the practically relevant effects were corresponding to the morning session. So the amount of light that you get in the morning is very much related to the sky conditions that you are exposed before you enter the test session. So this is something that we want to investigate much further. And then the final, so as I can say in here, there is non-significant differences for any of these variables. And then prior light exposure, again, we couldn't detect a specific directionality of the hypothesis under any of the conditions, under any of the, glare sensation votes. So again, we use a two-way analysis for the inferential test. Median differences, so the difference between the median of the log luminance in the 2 conditions, suggest that people that had been exposed to daylight before the test would have been more tolerant to luminance, so would have expressed their vote of glare sensation at a higher source luminance. However, most of the differences that we detected were non-significant. Significant differences were only detected in 2 out of 16 cases, although in both of these cases the direct tendency was detected, so people exposed to daylight was more tolerant to source luminance, and again, morning session consistently correspond to practically relevant effect sizes. I'm not going to comment on all the data and so forth. So these are the ones that wanted to point out. So what do we get out of all this? One of the things that we wanted to have is one single graphical display where all of these variables could be related to each other. This is a plot of effect sizes. So essentially, this is a plot that tells us how much each single variable influences the source luminance at which a glare sensation vote is given. We see, for example, that the chronotype has a very clear inverse relationship. So across all of 4 sessions, there is a consistent trend for earlier chronotype to provide their glare sensation vote at higher source luminance. However, we see something very interesting. The influence of chronotype is highest in the morning. Then it decreases at midday, and then it picks up again in the post-lunch dip. And the same thing happens with fatigue. Fatigue actually has a higher influence in the morning, so the effect size is more pronounced. Then the effect size decreases, and then it picks up again in the post-lunch dip, for then inverting its relationship in the afternoon. So obviously there is something about these variables that has to be considered on a day-long, I would say, basis. Because obviously we could see that the way in which those variables influence glare response could be related to that famous phase response curve of the metabolic functioning of our organism. Same thing about caffeine ingestion. Caffeine ingestion has an inverse effect, but its effect is actually highest in the middle of the day, and then it reduces in the early afternoon for then picking up again in the evening. So obviously these are all variables that have to be considered on a day-long visualization. For sky condition and prior light exposure, there is not much that could actually be said in this visualization, although it is clear that the prevailing sky condition and the prior light exposure do have an influence on the way in which people relate a source luminance to the glare sensation vote, particularly in the morning. So again, the morning session seems to be the session which is more influenced by either the amount of light that you've received before the test, and then obviously the sky condition, the prevailing sky condition, which could actually be very much related with this parameter. So the conclusions from this further analysis are the earlier chronotypes could tolerate higher levels of luminance at all sessions. This influence decreased at midday before increasing again in the afternoon. Subjects not having ingested caffeine had higher tolerance to luminance across the day. This influence was less substantive in the afternoon. And then consideration of age, gender, ethnicity, food intake, and photosensitivity did not lead to any practical significant effect, and there was no consistency in fatigue, sky conditions, and prior light exposure. So this is from data that was collected as part of the first experiment. However, none of these data were related to an experiment where people had to provide the glare assessment while engaging with a visual task, something that in the literature has been alleged to be influencing the way in which glare sensation votes are provided. So in order to try to resolve some of those influences, some of those traces of influences in some case, we designed a further laboratory experiment where we look both at the difficulty of the visual task and the influence of temporal variables on glare response. Before going further, probably I'm just going to need another about 15 minutes of this. So I wanted to ask if there is any question at the moment. Yes?
Regarding the sky condition, I'm very surprised.
Sorry, say it again?
Sky condition. I'm very surprised that you couldn't find any connection. If you imagine, as a personal experience, you are from a very bright place, you have the sun in your eye, and then you go inside space. Your perception of glare immediately changes rather than what the horizontal space. So I'm very surprised.
Well, obviously we had a pre-test procedure where people could adapt to the background luminance before obviously they provided the glare sensation. We were very surprised as well. So particularly in terms of sky condition and the prior daylight exposure, hence the reason why when we moved to the test room studies, so the tests that were done with the daylighting, we actually found some influences, and we're going to discuss that later. There was another question here.
Yeah, I mean, is it possible to relate this to DGP as well?
Yeah. Well, obviously, we used in this case, in the first experiment, the ISGI, because it's a glare index that has been developed for small artificial lighting sources. For DGP, obviously, we would need to have daylighting. So we use DGP as the predictor for all of the test room study with daylight, hence the involvement of Jan Fienold in particularly in the definition of the methodology for that analysis. Okay. Yes?
By removing all of the artificial stimulus then that take you away from just the glare response, you've kind of removed all the natural stimulus as well. So the second inextricably linked to glare would be thermal discomfort.
Yep.
So if you're sat in a commercial space and the sunlight's on you, psychologically you connect that to
Yep.
a glare issue as well. So you're taking away the individual's natural response
Yep.
to it and only having an artificial response.
Exactly. So laboratory conditions were essentially designed so that any other variable that in one way or the other in the literature or anyway in any form of potential sort of assumption could influence glare response have been either removed or controlled. So for example, the tests were all done at the same temperature. We were measuring temperature, humidity, dB levels in order to make sure that all of these parameters were, well in this case, experimentally controlled, while some of the variables were statistically controlled, so by using, for example, analysis of covariate, in order to make sure that we could focus on the effect of experimental interest, which is the alleged effect of time of the day on glare response. So this was purposely done in order to make sure that, well, the initial hypothesis was that this effect could have been very small. And if an effect is very small, obviously you have to provide experimental conditions such that you can really focus on that specific effect. Yes?
Yeah, I'm interested that we've got let's say a variation in sensitivity to glare with clock time.
Yep.
And a variation with chronotype. Is it then actually that our sensitivity to glare or perception of glare is influenced by personal body time? And that's what we should be trying to get to rather than clock time.
Well, yes, this is one of the comments I think that Steve made to the thesis that Michael submitted. Essentially, in this case, we have a very artificial way of looking at the body. We have an equally spaced number of sessions every 3 hours, although metabolism could actually be quicker in some part of the day and actually much slower in some other parts of the day. Again, at this point, we're just trying to detect an effect. Once we have the detection of the effect in the laboratory, and we know the variables that have to be controlled or masked, we can then move on to the test room, and obviously there is much more natural conditions that can actually be put in place. Although even there are a number of further conditions to be considered. As I was saying before, and as Michael would actually focus on at the end of his presentation, is now moving on to an analysis of visual response, visual performance, and chronotype, so metabolic behavior of the body. But in order to do that, we have to clearly measure biological proxies, so body temperature, core body temperature, scale galvanic response, and so forth. So obviously this is a more advanced study which will be part of ongoing research. This third experiment, consider that in the previous experience we had no task-related stimulus that people actually could relate the visual perception to. They were just abstractively looking at the glare source, which was made of a diffusive screen. This could actually, the artificial setting, one of the reasons for the scatter that we detected. So we thought that the further experiment could analyze the influence of task difficulty, and also at the same time look back at the influence of all those temporal variables and personal factors on glare response. We use number searching stimuli, so something which is still abstract but doesn't necessarily capture too much the attention of the subject for it to becoming engaging or for it to becoming boring, which we obviously do not want. In response to the question of before in terms of the scale, we then use in this case a visual analog scale, which is what I was mentioning before. So we use a scale that goes from imperceptible to intolerable, for people obviously to mark with a line on the scale their glare sensation. We also used, rather than ordered scale, we use visual analog scales for measuring all of the other temporal variables or personal factors. So for example, this is the visual analog scale for fatigue. Although then within the analysis, we then reduce all of those continuous scales into ordinal categories, so by dividing the length of the scale in 4 equal segments. The visual task was essentially, as I was saying, numeric, essentially find the number. The experimenter, Michael, would just call a number, and then people would have to find it within a list of 9 numbers that are arranged in a random position. We divided the task into 3 different groups. The first one changed in font size from 10 to 4. The second group changed in the character contrast. So we changed the background from 20 to 40, and then we distorted the information with vertical and horizontal lines. And then the third one changed the character contrast. So the contrast of the character with respect to the background changed from 50 to 35 to 25 to 15. Sorry, this is internal contrast, this is character contrast. All of the tasks were provided in the same font, which was Verdana. Before the test, all of the tasks were presented to an independent group of observers who actually rated them in terms of increased perceived task difficulty. So we have in here the mean and standard deviation of the task difficulty that each of these tasks has been associated with by the independent sample. So essentially we have these 3 groups of 4 tasks each. The study had essentially 3 aims. First of all, try to confirm or challenge the results of the previous experiments while subjects were performing a task. So at first we just look at the glare response for each task individually. The second one, we looked at whether groups of tasks, so the manipulation of the information between each group of tasks, entailed a difference in the variation of glare response. The third aim was, again, to study the influence of temporal variables and personal factors on the response given by subjects while they were performing with tasks. To avoid the loophole that we had created in the initial experiment where we had the same sequence for all subjects, we then used Latin square design for this experiment. So essentially we shuffled all of the sessions at which participants were requested to attend. So each participant would attend 1 session per day, so on 4 different days, and the order of those sequences was randomized, as was the order of the tasks. So we use randomization in both cases. The task was displayed 2.87 degrees higher than the glare source. This was coming from the results of a pilot study. And a pilot study also gave us an indication of the luminance at which the experiment had to be done. So in this case, we do something different from the initial experiment. In the initial experiment, we increase gradually the luminance of the source. In this case, we keep the luminance constant, and we see whether under a constant luminance, people give a different glare sensation vote. So the first experiment, we just increased the luminance, and we looked where the glare sensation vote was provided. In this case, we keep the luminance constant, and we see whether there is a difference in the glare sensation vote that people give. In order to relate the glare sensation vote and with glare index, we made a transformation which is similar to the one that Tuacharoen, I cannot pronounce it that, and Tregenza did in their analysis of view interest. So we scaled the glare sensation vote to the IESGI glare index by using the data that were provided by Hopkinson and Chauvel in their Hopkinson in 71 and Chauvel in their 1982 papers. So by using this comparison between GSV and IESGI, we transformed the GSV into a GRV, so a glare response vote. Glare response vote which was scaled to the IESGI, therefore suitable for assessing glare from a small artificial source. Again, we did the analysis of normality and Levine's test of homogeneity of variance, and we actually saw that data in this case were normally distributed, so we could perform parametric tests. If we look, for example, here at the 4 different tasks of group 1, and we focus only on one of those 4, we have the glare response vote, and we have the glare sensation vote, which is provided by the people. So the morning, the midday, the afternoon, and the evening. I can't remember which glare sensation vote this is. I should have written it in here. In this case, what we have, we see that as for every single task, as we move from the morning to the midday to the afternoon and to the evening, there seems to be a tendency for the statistical parameters of the GRV to decrease. So the same glare sensation vote is provided for a glare response vote IESGI with decreases from morning to evening. So again, we can see that there is the same tendency that we had detected in the previous experiment of a higher tolerance to glare as we move along. This is probably best explained by looking at the data, because obviously we had to do a number of different inferential tests in order to detect this experiment. The first one was a Mankova, so a multivariate analysis of covariate controlling for fatigue. controlling for fatigue, we could actually see that there was a significant difference between sessions. So the sessions provided a difference in terms of the tolerance, the luminance at which glare sensation was provided. We then did an ANCOVA, an analysis of covariance, which looked for significant differences between sessions for each task. So in this case, we have each of the 12 tasks, and we look at whether there is any significance in the 4 sessions, so morning to midday to afternoon to evening. Once controlling for fatigue, so we look at the second column, which is time of the day, we see that 10 of these ANCOVAs are effectively significant, and for all, we actually see that there is a practical irrelevance of effect size. So in this case, we can say that there is a difference between sessions, so we have to perform a further analysis, so a pairwise comparison, in order to look at the directionality and the relevance of that difference. We did contrasts for each of the tasks, and we can actually see that there is a tendency which is very much similar to the tendency that we found in the initial experiment, where we have difference between sessions that tend to have a positive effect size, essentially represented a higher tolerance to glare as we move along the day, but also that as the time gap between sessions increase, there is a larger variation in terms of tolerance to glare. And actually for 6 of the tasks, 3, 7, 8, 10, 11, and 12, the largest significant effects occur between morning and evening, which actually tells us that as we consider a larger time gap between sessions, we can actually infer the presence of a larger effect of time of the day on glare response. For other tasks, like for example 5 and 6, the largest significant difference was detected between the morning and the afternoon, so 6 hours. We have plotted them in here when we have the morning glare response vote and midday and afternoon and evening glare response vote. Again, the null hypothesis line is on the diagonal, and then we have linear interpolation. The linear interpolation in this case is always below the null hypothesis line. In this case, obviously, we have here the glare response vote for the same constant luminance. So a higher tolerance is represented by a lower glare response vote because the luminance is constant. In the first experiment, a higher tolerance was represented by a higher source luminance. So in the first experiments, all of the interpolations were above the null hypothesis line. Hence, we could say that the same glare sensation vote was given for a higher source luminance. In this case, the glare response vote interpolation is below the null hypothesis line, which means that under a constant source luminance, glare response votes are given at a lower level as we move along the day. Therefore, as you move from morning to midday to afternoon to evening, the same source luminance is rated by you as being less glary because your glare response vote is lower. So this essentially confirms what we had said in the initial experiment. We also see that there is an higher scatter of the data as we move from task 5 to task 6. Task 6 was rated with a higher perceived difficulty. Therefore, we can also infer that the task difficulty and an increased difficulty could actually be one of the variables to be considered in terms of glare response. We also looked at whether different manipulation of the data could have different effects on glare response. So in this case, we have the tasks of group 1, where we change the font, the tasks of group 2, where we change the internal contrast, and the tasks of group 3, when we change the character contrast. We see that there is a very similar tendency for as the task becomes, in this case, more difficult, the glare response vote changes. So we see that there is an effect of task difficulty on the way in which glare response vote is associated with the constant source luminance. But then we also perform, other than this initial box plot, an analysis of multivariate analysis of variance in order to understand how these variables, how this variation of tasks influenced glare response. So in this case, we grouped the tasks based on the manipulation that we gave it, and the size, so we changed the size of the font, internal contrast, and character contrast. We performed a maneuver, which was statistically significant. Therefore, this told us that there is a difference between the different test sessions depending on the manipulation of the task, and also an ANOVA for the morning, midday, afternoon, and evening. One thing which is interesting in here is to see that the effect of task manipulation, which is essentially measured by the effect size, changes, which means that manipulating the task in terms of changing the font size, or changing internal contrast, or changing the character contrast, has a different role in the effect that you have on glare response. So we did a further ANOVA. It seems like we're doing an analysis after the other in order to see where this difference lied. We have it in here. Changing the font size has the largest influence in the morning. So the effect size is 0.25. Then changing the font size has an effect on glare response that decreases in the midday, then in the afternoon, and then in the evening. So you go from 25 to 21 to 15 to 16. Changing the internal contrast, so essentially the contrast of the background of the task, has an inverse effect, has 0.05 of an effect in the morning, and as this tends to increase throughout the day, while changing the character contrast has a very similar tendency as the very first, so the size, which means that by changing the size of the character and the contrast of the character, you are directly manipulating the information of interest within the task. While changing the internal contrast, you are indirectly manipulating the information within the task. So these two manipulations have a different effect on your variation of glare response throughout the day, which is an interesting finding. We still don't know why, but we'll try to see what actually comes out of it, because obviously this is something to do in the way in which, for example, we read information out of screens, tablets, and paper, and so forth. So glare response depended on task difficulty. Relations varied along the day. Inclusive feature of the task may affect temporal variation. For font size and character contrast, the largest significant difference were in the morning, and direct manipulation decreases along the day, while temporal variation of glare sensation given by the internal contrast strengthens with time of the day. So indirect manipulation has a larger effect at later times. We move on to the final analysis, which is the effect of the temporal variables. We measure the same variables as before, but obviously in this case we have temporal variables which are measured while people were engaged with the visual task. So we have somehow reduced the abstractions due to the tests, due to the experiments. Again, in here we did a number of tests. We did the JT test, which looked at trends within the data. The Kruskal-Wallis analysis of variance looked at whether there was differences between the sessions. And then a Mann-Whitney U test looked at where this difference lied. In here we have the 4 sessions, morning, midday, afternoon, and evening. We have the glare response vote on the y-axis, and then we have the ordered categories of fatigue. We said before that we measure fatigue on a visual analog scale, so we ask people to just tick on a 0 to 10 centimeters long scale their level of fatigue. We reduced that continuous scale into an ordered category by just dividing those 10 centimeters in 4 segments of 2.5 centimeters each. And then we assign some labels to each of those segments. So not fatigue, not much fatigue, slightly fatigue, and very fatigue. Don't look at the semantics. The semantics we have put at the end for the interpretation. People did not look at these semantics. They were only had to rate their fatigue on a scale 0 to 100, no fatigue to very fatigued. In this case, we see that as people become more fatigued, the glare response vote increases. So in the morning, people which are not fatigued provide a glare response vote from a constant luminance at a lower level than if they have a higher level of fatigue. And this is something that actually is found throughout the day. Food intake, in this case, we see an inverse tendency. The more food people had, the lower the glare response vote. In this case, obviously, what I'm saying is just the result of not only the interpretation of the box plots, but also the statistical analysis and the significance that we found both in the JT test and in analysis of variance. Caffeine ingestion, in this case, we found a direct relationship between caffeine ingestion and the glare response vote. So there were substantive differences supporting a direct relationship between caffeine and glare. The higher your caffeine intake, the higher the glare response vote that people provided at all 4 sessions from the constant source luminance. We also measured mood. Again, this is a self-perceived mood. We didn't really find very clear indications. There are some potential inference that a higher mood lead to higher glare, but I think that we don't have sufficient analysis and sufficient rigor in the analysis in order to state that. We look at daylight exposure. We found a direct trend. So the higher the exposure that people had from daylight, the higher the glare response vote, meaning that they actually rated the glare source at a higher glare response level. And finally, we found the sky condition. Again, in this case, you can also see it from the box plots. There is not a clear univocal tendency which can be found. To sum it up, because I don't want to take more time to Michael, we looked, again, a similar visualization to what we had before in terms of comparison of effect sizes. This is actually the analysis that we did with the task and the font size, the contrast, the internal contrast, and the character contrast. We can see that the effect sizes, so changing the difficulty of the task, has an increasing effect as we increase temporal gaps. So as we move from morning versus midday, as morning versus afternoon, as morning versus evening. The rate of variation is not consistent. So obviously there's no linear relationship between variables, which means that one of the outcomes from this analysis is that task manipulation and task difficulty can mediate the effect of time of the day. The first experiment had told us that there is an effect of time of the day. That effect of time of the day can be mediated by the difficulty of the task and how we've actually manipulated the task. The temporal variables are here plotted with their effect sizes and the effect that they have in the morning, midday, afternoon, and evening. Fatigue has the highest effect on glare response, which is actually going back to the question that you asked before. This effect is particularly relevant in the morning and in the afternoon. In the morning and in the afternoon, fatigue has a direct relationship with glare response. So the more you are fatigued, the higher your glare response vote, which is something that seems somehow logic. Interestingly, at these 2 sessions, there is an inverse effect of food intake. So the more food intake you had, the lower your glare response vote. However, fatigue and food intake have non-significant influence in the midday and in the evening. But in the midday and the evening, caffeine ingestion has a significant effect. A direct relationship is exactly the same relationship that fatigue used to have. So from this data, what we concluded is that, okay, all of these temporal variables are not independent from each other. They are very much closely linked. And it could be, for example, that caffeine ingestion could mask fatigue. But also food intake could mask fatigue. If you had just had breakfast or had just had sort of a snack, you may perceive a lower level of fatigue. So in the test room experiments that Michael is going to present after a break, I suppose, these are all parameters that we need to consider. We couldn't find much in terms of mood, prior daylight exposure, or sky condition, probably due to the fact that we used self-assessment. But there are some indications that they tend to vary in the same direction, particularly prior daylight exposure and sky condition and mood. And again, this is completely conjectural, but if you are exposed to a much higher level of daylight because it's sunny, you're very likely to be in a good mood or something like that. I don't know. This is conjectural, but clearly those variables have to be considered in conjunction with each other. So the conclusion is that from the laboratory studies, we conclude that subjective glare sensation show a tendency to decrease as the day progresses. So we could actually say that the effective time of the day is higher as you proceed along the day. However, this effect is influenced by the level of visual discomfort, but also by the task difficulty and manipulation. There is a direct relationship between fatigue and glare response, inverse effect of food intake, and the direct influence of caffeine. There is some evidence of an influence of mood, prior daylight exposure, and sky conditions. However, we do not have any conclusive and consistent inference to be made. But also there is very likely interaction between variables. So this is all that we use in order to find the methodology of testing and analysis and the variables that we had to control for moving to a daylit condition, which then is going to be presented by Michael in the second part of today. I think I've taken much longer than I wanted to take, but I hope it sort of made sense. Thank you.